Well, good morning, everybody. How are we doing? This is Jeremiah, and we are having a webinar today. This is one of those fun ones driven from the tech support side. We get, as you can imagine, people who are like, "Hey, my land effects is going really slow," or a lot of times, actually, more honestly, we might be in a remote session with someone, and we go, "Yeah, you're." Everything's running really slow, and people just don't notice because they think that it's just that was the normal speed. So this webinar is going to give you a lot of good tips on how to troubleshoot, how to determine if something is actually operating slowly, and some steps on how to fix it. So if that sounds fun, then you're in the right place. We are recording this, so it'll be up on the website later today. And we are here live doing this. So you are welcome to ask us questions. We are certainly going to get into some technical things. So please feel free to go ahead and click that Q&A button at the bottom of the screen. And in fact, I would even recommend you do that because you'll be able to see the answers that we type to other people's questions. So that helps to give you a interactive sort of feel. You're not just watching a recorded one, although like I said, it is recorded, so you might be in the future doing exactly that. But anyway, enough of my yammer. I'm going to let Bennett get us going. Let's rock and roll.
All right. Thank you, Jer. So yeah, welcome everybody. I think Jer did a pretty good job explaining what we're going to be doing here. So we'll take a kind of a brief look at some system stuff and some drawing related or design related things that might cause you some slowdowns this morning. And yeah, like you said, it's surprising that how adapted or used to a certain level of performance you can be. So sometimes you don't even notice something's going on. So this is me. That's just kind of a joke that kind of goes around. People tend to call me over to fix something, and by the time I get there, it just starts working again. I don't know why. It's kind of always been like that. I think technology is afraid that I'm going to throw it away if it doesn't cooperate. So this is just a quick little reminder that most mostly everything we're going to cover today is derived from our slow performance knowledge base article. It basically covers, some potential pitfalls you might run into and the solutions for those, or at least some diagnostic steps to try to narrow down the cause of the problem. Um, so if you have any questions, the link to that article will be posted on the webinar page for this. And you can always get to it by just going to landeffects.com, hitting our support page and just searching for slow performance. It'll be the top result. All right, so a few different things that can give you grief or make your computer feel like it's dragging as far as land effects is concerned. The database connection is a big one, especially if you're working on a multi-user environment where the database actually isn't on your system. That's generally the only time you're going to run into a delay with the database. And that can be with cloud data or local data. So we'll kind of take a look at both of those. The landeffects.com web connection, uh, even if you're not using cloud data, there's still a cloud aspect to the software. So you still have to be able to reach landeffects.com. And fortunately, we have endpoints all across the globe. So depending on where you're at, you're automatically connected to the one that you have the best connection to. So that should always be super speedy. But we'll also take a look at what can happen when you're looking at a delay with that connection. Next up is overall network speed. So not just your internet connection to the LandFX website or your database, but just the connection between your workstation and your router. So if your workstation is connected, if you're using Wi-Fi, you might not have a great Wi-Fi signal, and that could reduce your speed drastically. Your computer hardware. I know we talk about computer hardware a lot, but it is important and it can have a severe effect on performance. Like we're talking, go make a cup of coffee, come back. All right, we're still not done. And lastly, we'll take a look at some design versus configuration slowness. So differentiating between when it's a computer issue or a networking issue and when it's a design issue or in a particular drawing set. All right, first up, let's take a look at the DB connection. So with your database connection, you have multiple points of failure in your chain. You have your database host or server. You have the client workstation, which is where you're going to be using CAD. That's where you'll be working on your drawings itself. DNS is pretty much only going to come into play when you're working in a remote database fashion. So if you have a multi-user setup with an Office server, and your internet connection is really going to come into play if you're using cloud data. Like I said, it's still going to affect the non-database related cloud items, but it won't be quite as drastic. So like I was saying, DNS is the most common cause of headaches with your DB connection, simply because it handles it. Most of the time you're working with a computer name like my server or my PC name. DNS translates that name into a physical address so you can actually connect to it. So the name is primarily for people. The computers don't use the name. They use the physical address. Okay, so you have a few different items here, obviously. So the ODBC connector on your workstation is what makes the connection from CAD to your database. And you have options. You can use the host name, like we're showing here on the left, using my server, and you can also use the physical address. So when you use the host name, it has to go through DNS. And one of the most common issues we've seen is having improperly configured DNS, where your query goes out to a public-facing DNS server, and what that means is a public-facing DNS server handles responses for like Google.com. It's publicly accessible. You can be connected at your friend's house. You can be connected at the office. You can be at the beach on your phone, and you can go to type in Google.com and you'll end up at your page. The problem with this particular setup is when you have an Office server in a private office, most of the time that's not publicly accessible. You don't want it publicly accessible. If you've been following the news regarding tech for the past, 5 or 6 years, the number of data breaches and hacks that have come out have ballooned like no other. So having a publicly available server is a full-time security gig, and a lot of companies don't want to deal with that. So 99% of the time your server is going to be private facing. So when your traffic routes out a public DNS server, what happens is it goes down this long chain of different response servers while they try to find it. And eventually it comes back to your computer, and then your computer tries to look on your private network. But that takes time. The first DNS ping waits for 2 seconds. Then it tries again, waits another 2 seconds. Then it tries again, waits 4 seconds. And then it tries again and waits 8 seconds. So it can really delay things. And that'll happen every time you try to do anything with that name. All right, so this route, we're using the physical address. So instead of using the host name or my server, we're using the actual address for the server on the right. And when you do it this way, you completely avoid DNS altogether. Your connection, you just connect straight to the server because you know where it is. Your machine knows where it is based off of that address. This is a solid workaround for the DNS issue, especially if you don't know a lot of DNS or know a lot about DNS. Like I don't know a lot about DNS. I know enough in tech to get myself in trouble, but networking is one of those things where I haven't really dove into it a whole lot. So using IP address is a solid workaround. There are a few snags with that. The primary one is going to be if you're using DHCP or dynamically allocating these physical addresses, which most people are, they just let their router do that because it's fast, it's easy, you plug something in and it just works. The problem with that is they expire. Most of the time you're looking at a lease time of 1 week. So if you find your server's IP address and you set it to that, you might find that you work fine, and then all of a sudden you can't talk to it anymore. So if you're going to use physical address like this, you have to go in and set static IPs either on the server itself or at the router level. Personally, I prefer to do it at the router level because you have one location to do this for all of your devices. Whereas if you do it at the device level and you have 20 workstations, you have to go around to all 20 workstations to change that. And then if you swap a workstation out, you have to make sure to find that specific workstation to change it again. Whereas if you're looking in the router view, you get a list of all the connected devices and you can set static addresses there. I was trying to replicate a broken DNS environment to showcase what it would look like. One of the diagnostic steps that we recommend, or we recommend using for testing that, is to test your ODBC connection, which is that database connector from the workstation. Unfortunately, no matter how much I tried, I could not break my DNS and delay the connection. So what I'm going to do here is I'm just going to pull up the ODBC connector to show you what a quick response should be. Generally, it should be nearly immediate, especially if you're on the same network. Most of the time, you're only going to start seeing delays if you're working remote. Like I know a lot of people are working remote now due to the pandemic. So, and if your local data, you have to go back over a tunnel or a private connection that goes back to the private network at the office. So if you're doing that, you might see some delays if it's not routed correctly. But that connection successful message should come up almost immediately every time. Any delays here is going to snowball once you're working in the software. I mean, you try to run a command and it's got to go out to the database and wait for that response. So every time something like that happens, you're going to be just chugging and waiting. So you definitely want this test to have a nearly immediate response. Okay, so that database stuff is relatively quick, especially since I couldn't simulate a broken DNS. So we're going to move on to the web connection. Now this is going to be basic. It's a web connection. You know, it's like trying to get to google.com. It needs very minor things. And it's super simple to test. It does utilize Internet Explorer, even if you don't. I know almost everybody these days is using Chrome. You have to actually dig to find Internet Explorer now. Microsoft has now pushed a new update. So now when you try to search for it or pull it up, they still try to push you to Edge. So that's a little bit of a snaggle, but you just have to use Internet Explorer. You have to reach aws.landfx.com. And the system automatically routes you to the endpoint with the lowest latency. So we have these AWS endpoints all around the globe. So regardless of where you're at, you'll automatically be directed to the one that you have the fastest connection to. What I want to do is I'm going to show you what happens when you don't have a quick connection to that endpoint. So you can see the kind of performance you should expect when you, do I still have, oh no. Well, that's unfortunate.
What'd you break this time?
I had to replace my VM yesterday, and apparently I forgot to reinstall my VPN.
It says right there.
That's on the Mac side, and if I turn that on, I'll probably disconnect from the webinar. So that's a bit of a bummer.
Well, you should, the way they're doing it is Edge should use the same connection. So should still be able to use Edge.
Oh, no, I was referring to my VPN.
Oh, okay.
So you can see here, aws.landfx.com. This is the endpoint that the software is going to try to hit. Down at the bottom, you'll see it's connected to US West, California. And that's our California-based instance because we're in California. Now, if I was to simulate my connection from Frankfurt or the UK, this page would have a slight delay in its loading because I have a latency to that endpoint or a delay response from trying to reach it. It has to come back and say, oh yeah, here's your data. and there's a bit of a delay there. Yesterday when I was working on it, I had about a 200 millisecond delay. Doesn't seem like a lot, but 200 milliseconds with every data packet or data burst that goes back and forth, it adds up pretty quick. Okay. So your overall network speed, we're still referring to speed a lot. That's going to be a primary thing here. And a lot of your speed is going to be coming down to a combination of your network card in the computer. That's going to be regardless of whether you're hardwired or over Wi-Fi. Basically, anytime you have a network connection, that has to go over a network card. You've got your router. So you could have a 10 gigabit card in your computer, but most routers, especially in small offices and home use, things like that, are 1 gigabit, 1,000 megabits. More than sufficient for CAD use, way more than sufficient. You have your individual connection points to consider, which if you are hardwired, that's going to be each end of the physical wire. We have, I've seen multiple times in the past, it's a cable. You know, it's just like a USB cable or your phone charger cable. When it's unplugged, people tend to just grab the cable and pull. What happens is that pulls the individual wires out of their connector. So you may end up with your gigabit Ethernet cable only giving you partial bandwidth. So that's something to consider. The next up is signal quality with your Wi-Fi. If you're primarily using Wi-Fi, which let's be honest, most people these days are. It's convenient, it's easy, you're free to move around wherever you're at, you'll stay connected. There's a few considerations to think of when you're working with Wi-Fi. Now, what I have here on the left is a signal quality readout. So I took this the other day. This is my computer in the same room as my router. The channel is your broadcast channel. So when you're in an area with a lot of congestion, you have to choose a channel that's not heavily congested, and that's how you maintain good signal quality. The RSSI and noise are just numbers that are used to generate your overall signal strength. The transmit rate is what we're focused on here. 866 megabits per second is almost as fast as a hardwired connection, which is great. That's awesome to be able to have no cables connected and wander around and have an almost full gigabit connection. The thing to consider is Wi-Fi does not like walls or appliances. Now I take the same computer, move one room away through a hallway. So there's 2 dry walls it has to go through, and my transmit rate drops to 390 megabits per second. We're talking maybe 20 feet, and I just lost half of my connection speed. Now, if you're only working with CAD and you're not working with very large files, you may not notice this, but how often is your computer only working with CAD? Most people have email running in the background, Windows is running, you probably have updates downloading because we all know how much Microsoft likes to push out updates. If you're on a Mac, you have 2 operating systems running and you have 2 systems trying to pull bandwidth. So losing half of your bandwidth by moving 20 feet is pretty significant. So that's a consideration to think about if you're using Wi-Fi. All right, so I'm going to get a little bit nerdy on everyone here. If your eyes glaze over, I totally understand. But this helps kind of break down what's happening or what these acronyms mean. So network speeds are going to be measured in megabits per second or Mbps, whereas your files are measured in megabytes. So 1 bit is your speed, but 1 byte equals 8 bits. So basically for whatever file you're going to be trying to transfer, take your network speed or take your file size and multiply that by 8. That's the network speed you need to be able to pull that down in a second. Now, this is best case scenario, of course. There's, of course, overhead for all protocols. So these numbers are estimates at best. Your average drawing is about 10 megabytes, at least when it's close to completion without corruption and clean, ready to go. That would need an 80 megabit per second connection to access in 1 second. Not that much. Now, if you have 5 other drawings in that folder, XREFs, as you usually do, you now need a 400 megabit connection to access that in 1 second. Now, you will very rarely ever actually access that in 1 second. It's just a example of how quickly your connection speed balloons. So the biggest slowdown you're going to run into with file sharing is latency. Just as an example, I took a blocks directory out of a standard LandFX installation, estimated it at about 7.5 megabytes. TCP protocol transfers, which is what's used for file sharing, for network file sharing, that's the protocol. You're going to average 95 megabits unless if you have a professional IT team that goes in and does network administration and optimization, you can absolutely get faster transfers out of it. But for the most case, you're going to be sitting around there. So your round trip latency, that is the time it takes to go from your computer to the server and pull that data back to your machine. 0 ms is perfect, or 0 milliseconds. That's going to be something you should expect if you're on the same network as your server. So if you're in an office and your server is hosted in your office, you should expect 0 millisecond response, 0 to 3. Anything over that, and generally you're looking at either an issue, possibly a firewall slowing things down, or a connection issue. With 0 and up to 30 milliseconds in the same office, time to load the planting symbol selection dialog should be nearly immediate. Those symbols should populate very, very quickly. Bump that up to 60 to 90 milliseconds, you're looking at anywhere from 1 to 2 seconds delay, depending. And 60 is not that far off. I mean, my connection to Google from here is between 30 and 50. So if I was using cloud data, I should expect the same kind of connection to the database. The time to load your symbols with a 2% packet loss, not that unheard of. Pretty serious degradation in performance. The reason for that is when you lose a response packet for the TCP protocol, it cuts your transmission in half. Every time it loses a packet, it drops it in half to say, okay, we need to slow down, wait for this to try to catch up. It does eventually start speeding back up, but if it loses another one in that time, you drop drastically. So you can go from near immediate to 1.5 seconds to 10 seconds with everything that has to query that. So latency can have a massive effect on performance, especially when you are making constant calls back to the software. Now, something else I did want to talk on regarding latency is shared online folders. We've seen a pretty substantial surge in these lately, especially with cloud data. You know, you've got Google Drive, OneDrive, Dropbox, and I thought that this was going to be a perfect example and a good time to showcase this issue. It looks like they've updated their platforms a bit because I was not able to replicate the problem, but a lot of them have moved over to this store online, download on demand system. So you've got always keep on this device, which means it pulls it down to your machine just like it would if it was on your desktop. You have the file on your machine. Almost all these providers have a free up space or store online only option, which means you have a quote unquote link to the file on your computer. And when you try to access it, it pulls it down. It downloads it at that time. The problem with that when you're using this with an application is the application expects a very low latency, almost immediate response when it has to access a file. And when you have to wait for another application to reach out to a server, download a file, and then say, here you go, it drastically affects performance. Like we used to see anywhere from 5 to 10 minute delays just trying to open the software. If you're using FXCAD, it could be a pretty drastic delay there. So I wanted to talk about this. It's very, very important to make sure when you're using LandFX in a shared online folder, like one of these platforms. And I mean, there's so many of them out there. OneDrive, Dropbox, Google Drive, ShareFile, SugarSync, Box. Like the number of these providers is ballooning every day. So if you're using one of them, I recommend checking with them with the producer of your platform to make sure that if they have this option, that you enable it at least for the land effects folder and also for any drawing sets you're working on. Because having drawings downloaded on demand would also delay things. So you don't have to download your entire drawing library, because I know a lot of people have massive libraries, which is perfectly fine, but at least a particular project set that you're working on, set that one available offline while you're working on it. And then when you're done with it, put it back to free up space or store online or whatever the option is for that platform.
We did get a good question here, which is, how do you test for this latency, and also how you tested for that the Wi-Fi speed?
For sure. So actually outlined in the slow performance article, a very simple test for latency, at least as far as land effects is concerned, is just to pull up the plant symbol dialog, generic plants as an example. So let's go ahead and do that really quick. Considering the folder structure is so small and everything is stored locally on my machine, the response should be near immediate. It should be very, very quick to load in those symbols. Dang it, I really needed that VPN going. So you can see here, like it's snappy when you change. No, well, it was. Did I break it? Okay, that wasn't snappy. We didn't download, did we?
Yeah, that's a great example. It's a great example of, it's a little sluggish, but now going back to like evergreen, it should be instant.
Yeah.
So that is just querying AWS for what blocks are available in that folder, is what that looks to be. But great. It's nice to see one of these sorts of real good examples of how do you gauge what is quote unquote slow.
Yeah. Yeah, I don't want to try to turn that on. Dang it. I'm trying to think of another way. I was going to flip the VPN on and off and show the kind of performance we get when we add latency into the equation, but I don't think I'm going to be able to do that.
But I think it's all right. But I think like even in that example, that was a nice example of just seeing that, there are cases in the software where you'll see that, a multi-second hit. And certainly like that, the first time it brings up that any folder of blocks, a few seconds there, in just that session, and then it caches that information, and then it's fine. But if that gets to be 9, 12 seconds, 15 seconds, now we've got a problem. And I think that's a good overall rule of thumb, is for the most part, we try to have all of our dialog boxes be nearly instantaneous, might be a handful of seconds, but something starts to get beyond a handful of seconds. Every time you bring it up, you have a performance issue, and that's definitely something that we can address.
Yeah, definitely double digits. As far as seconds waiting for a dialogue to get back to you is, I would consider, far too long. I've been working with, I'm a techie. I upgrade my stuff way too often. So I'm used to getting near immediate responses from things. Like if I hit Chrome and open Chrome and it doesn't pop up within a few seconds, I start like, what is happening? Why? So yeah, if you're waiting double digits for something to respond, as far as just loading up a dialogue or trying to pick a symbol like that, chances are there's a configuration issue or a connection issue that can try to speed that up. Since we're on the topic, computer hardware. Now, we talk about computer hardware a lot because it is important. If you work on these things for X amount of hours a day, it's important to make sure that your hardware is up to date. It's in good shape, especially when you're working with like hard drives. The spinning style hard drives, they have a failure rate. They have moving parts. So we're primarily talking about your storage medium here. And that's going to be solid state drive hard drive. Now, for these tests that I did, I used a 1 gigabyte file, and that's just a 1 gigabyte text file. And Q1 is a queue depth of 1. That means you have one process writing to it, which is standard, especially if you're working with CAD. You're going to have one process reading or writing to your drive for your primary use. So for your max read and write speed, this is the absolute most your drive is going to give you. Most of the time, you're not actually going to see that, at least when it comes to SSDs and application use. SSDs are really optimized for random access and sequential access, so multiple processes. You can see your hard drive is topping out at 134 megabytes per second read and write. It's not terrible, but it's not that great. It's enough for an everyday use case. But you can see the solid state drive just absolutely decimates it, like not even in the same galaxy. The most important thing here, though, is your random access. So what that means is your application data is very rarely stored in a sequential row. So it's all zeros and ones, but your data is written to your storage medium to the first available empty space, which is great if you have a brand new drive that has never had anything on it, because everything's just going to be written from start to end. But that doesn't happen in the real world. You know, you download a file to install Chrome, as an example. That goes in your downloads, so that takes up a spot on your hard drive. You install Chrome, that goes in the next spot. Then you delete the installer you just downloaded. Well, now you've got an empty spot back at the beginning of your drive. And that compounds over time. So random access is pulling data or writing data to different parts of the drive quickly. So for this test, it was a 4 kilobyte file, very small, queue depth of 1, simulates your average data expectancy. You can see your regular hard drive is abysmally slow here, and that's because it has moving parts. You have a spinning physical platter inside that the data is stored on, and a read head that has to travel all across the drive, and that's what reads and writes the data to it. Sets zeros and ones on the platter. So when you have scattered data like this, you're limited by how fast those mechanical pieces can move. Solid state drives don't have that problem. There are no moving parts. It's all flash memory, so it's all just done by electricity, resistance, basically. So solid state drives are fantastically better for random access. You'll see the speeds aren't drastically different here. I mean, read speed's what, 3 times as fast, almost 4 times, and the write speed's about double. Doesn't seem like that much, but we're going to take a look at a use case here in a second that showcases why this makes such a big difference. Lastly is your input output operations per second. That's the most operations that your processor can request or send to your storage medium per second. So while you're working in CAD, you have Windows running in the background. You've got Windows updates. You probably have an email client. Chances are you have a web browser, maybe Spotify. You know, there's so many things running in the background, and 90% of the time they're going to be accessing data out of RAM, but that has to be loaded from your drive. So your input output, that's going to be how many operations your storage medium can handle total. And modern processors can handle a lot of operations. So again, the hard drive's not bad. They've been around for a long time. They do work, but solid state drives are just next level. Let's go ahead and take a quick peek at an example to put this in perspective, because I know we can talk about numbers all day long, but numbers are numbers. And I mean, my memory is so shot these days that examples are my friends. All right. So this VM on the left here is running on my machine's internal solid state drive. The virtual machine on the right is running on a standard spinning hard drive that I've got over a USB dock. This is the drive that I did those speed tests on. So let's go ahead and fire both of these guys up so you can see the difference in how long it takes for, sorry, I've got my presentation view taking up part of my screen. The difference in just a machine boot time as an example, because this is just a, okay, Parallels is going to keep resizing my VMs. It's just a quick example of one particular situation using your drive. And this actually came up the other day. A user reached out to us and reported a very slow performance with launching FXCAD for the first time. And the reason for that is the first time you launch any application, it has to be pulled off of your storage medium and loaded into RAM. So RAM is, it's another storage medium, but it's volatile, which means every time you turn your computer off, it's cleared, it's deleted. There's nothing left on it. So if you're working with a slower storage medium, that first launch is really going to drag. Dang it. Okay, so you can see the solid state machine booted up a heck of a lot faster. Granted, today the hard drive machine did boot up a lot faster than my initial test. The first time I did this, my SSD machine booted, had to reboot and launched FXCAD before the one on the spinner even reached the desktop. And these are the same virtual machines across both of them. Oh, are you actually ready for me to do things? Okay, so to show you what I'm talking about as far as first launch and memory. So this is an easy dialog to reach. Just right click your taskbar, go to Task Manager if you're on Windows 10, and then you can go to Performance. The Performance tab is a standard option, then go down to Memory. This will show you your total available memory as well as what's in use, what's in standby, and then what's free. So nothing's touched it yet. Let's go ahead and launch FXCAD. Now, yeah, here we go. It'll get there. It'll get there. It's trying. It's trying. I'm watching the activity light here. It's going absolutely ballistic. So it is working. This is just what we're restricted to. Okay. Are we ready to go in the solid state? Almost. Yep, we are good. Okay. Solid state's ready to go. Now, obviously, oh wait, did I did. Obviously, that was a lot faster for the first launch, which is awesome because if you're a normal human being, you probably open and close applications a lot throughout your day. So having first launch be speedy is an awesome thing. I kind of got to wait for the spinner one to catch up here. Jared, did we have any other questions while this guy's kind of chugging along?
The other was also just, where did you check your Wi-Fi transmit rate? That was kind of neat. I'm looking for that myself and I can't find how to do that.
That was from my MacBook. So if you have your Mac, you can hold the Option or Alt key and then click your Wi-Fi icon and it'll give you that full breakdown.
Wow. What if you're on a Windows machine?
That one is yeah, that's a I don't have a Windows machine connected to that, but I believe you can click your little network icon, and then if this was Wi-Fi, you should be able to just click it and go to properties, and it should show you your transmit rate.
Excellent.
Okay, reloaded? No, we're still thinking. And I mean, yeah, this isn't even, there isn't even anything running in the background here. I just got Google Drive and OneDrive. So this is a pretty vanilla system here. And I mean, it's not the USB connection that's restricting it because we're going over USB 3. So that does 500 megabits per second. The drive only does 134. So the drive is our limiting factor here. Now, since we were talking about the first load up, you can see our memory in use has gone up a smidge. Both systems are sitting closer to 2.5 gigs. Yesterday, they were sitting closer to 3. So I might have opened up a DWG, or I was poking around with a project. Let's try that, see if we can load it up. It'll still work for the example. Just trying to verify. No, 2.5 still. 2.5. Okay. Well, that's fine. We can work with 2.5. Let's go ahead and close cat. Okay, bye. Do. Close. I guess computers don't just like working around me. Okay, there we go. All right, so you can see we dropped back down to 1.7 gigs in use on the spinner. We're back down to like 2 gigs here, but our standby memory's gone up, especially on the spinner. So standby memory is quote unquote cached memory. And what that means is once you open an application in Windows, it's loaded off of your hard drive into memory or RAM because it's infinitely faster than your storage medium. When you close the application, it's not just dumped out of RAM. It's stored in RAM as long as you have enough available. So as long as you have free memory, when you open another application, it'll eat up into the free memory. And your previous applications are still here in standby for future use. So let's go ahead and fire CAD back up again. So what it's doing right now is it's actually loading the application out of standby RAM instead of pulling it off of your storage medium. And as you can see, the spinning hard drive is nearly as fast as a solid state drive. So pretty much no difference there in load up time. And you'll see that behavior across the board. So you'll see that with your web browsers, with your email clients. Some machines these days have what they call solid state hybrid drives. And what that is it's a spinning hard drive with a very small amount of flash memory. Like if you have a 1 terabyte drive, I think they usually have 64 gigabytes of flash memory. And it works very much in the same way that your in use and free memory, or standby and free memory, works with your RAM. For some reason, this one just doesn't want to close on me. It basically takes a small amount of your storage, that's 64 gigs, and it does the same thing your RAM does. So applications that go into standby, it shovels over into that flash memory built into your hard drive so that it's permanently, or at least not permanently, that's the wrong choice of words. It's temporarily on a faster storage medium for faster access. And the drive chooses, based on data that you access on a frequent basis, what to put there. So you can get slightly better performance out of those, but due to the small flash capacity, they're not quite as useful as just a standard solid state drive. That's a good question. What's a failure rate on SSDs? I have had, in my experience, one SSD fail on me, and it was a very, very old drive, like one of the first generation drives. Most solid state drives these days, let's use a Samsung 1 terabyte as an example, will have a terabytes written endurance. I think the last one I was looking at was over 100 terabytes written. And if you're just an average user, I mean, you'll use a couple of gigs a week probably, and it's 1,000 gigs for a terabyte. So most SSDs are coming out of the box with a 5-year warranty. As far as data loss is concerned, unfortunately, there's not much warning when an SSD fails. There's no spinning parts, so there's no slowdown. The controller in the drive basically just flags the sectors as bad and turns them off. It stops using them. So it starts using other sectors. So you may see a reduction in drive size. You may actually see that start to go down. So if you have a 500 gig drive, you won't actually get 500 gigs out of a drive. But let's say you had a drive that said it had 254 gigabytes of space, and one day you turn it on and you're down to 223. That would be a solid indicator that you have a problem, and I would back up your data immediately. Also, to avoid data loss, backups. Never expect your computer to just run. Always expect your computer to crash, get hit by a virus, power outages, fry it, back up your data. There's too many options out there to have cheap backups. I think I signed up for one this year. I think I paid $10 for a year subscription for 5 machines, and it backs up online. But it's not overly expensive anymore.
Martha has a great question. It's just, how do you check to make sure whether or not you have an SSD?
So that's a little bit trickier. There's no, well, actually, I'm not sure if there is, but as far as I know, Windows doesn't have a built-in just, yeah, this is an SSD. So my go-to is I go to the hardware. Unfortunately, I'm on a virtual machine. So this is telling you the name of the virtual machine drive file. But usually you'll see the hardware name or the model number of your drive here. And that's that you can punch that into Google and it'll usually pull up that specific drive.
You should also, I would think I was trying to think you might be able to hear a hard drive, but I guess a pretty modern hard drive, you might not be able to hear it running.
They are pretty quiet. In my home server that I was running, I had 8 terabyte helium filled drives, and yeah, you could not hear those things running at all. Dead silent. It was a trip. But most people are going to be working off of a desktop or a laptop, so your drive's going to be buried behind, a couple panels of metal, and you got fans in there already. So chances are you won't hear it spinning. You might be able to put your hand on the computer and feel it spinning, though.
It literally might even be easier to just track down the order. I mean, if you bought it from Dell or whatever, it's going to be right there on the description of the computer.
That would be the go-to. Yeah. Especially if you're on a laptop, because they'll have the model they'll have the model on a sticker on the bottom of the machine. And that will, you can just punch that into Google as well and look at the standard specs. It does get a little bit tricky when they do offer an SSD upgrade for that model. But yeah, if you have the order number, definitely that's the way to go. Okay, so design versus configuration slowness. So everything we've talked about up to now is configuration issues. You're talking about, networking speed, your latency, your database connection, all that jazz. So to differentiate, once you actually get into your design, there are just some things that will take time, especially with irrigation. You're going to have thousands of objects in this file. And if you have hundreds of drip line areas, or you have a ton of loops on your main line, that creates hundreds of valve paths, which take time for the software to chug through. Fortunately, we do release updates frequently, and a relatively recent one took a irrigation workflow, or Joe, was it a Verify?
It was primarily Verify. Yeah. They go, gosh, it takes like 45 minutes to run Verify. And we weren't able to make it perfect, but dropped it down to about, it was a massive plan. And the way they drew it, they had 4 pipe transition points inside every drip line area. And there was hundreds and hundreds and hundreds of them. And that's going to take a long time. There's no reason to put 4 pipe transition points inside every drip area. And that just simply added to it. But that's always a good example, is just, if it's a particular task in a particular file, that obviously, can happen, takes 30 minutes to size the main line. Well, send that file into us, and maybe there's something that we can do to try to drop that down.
Awesome. Yeah, I mean, 45 minutes to 15 minutes. That I'll take an extra half hour a day.
Yeah, right.
All right. So diagnosing colorized plans. Color adds there's it's gonna cause some drags, especially when you're opening, saving, or plotting the file, just because of the additional content that color adds. You're no longer working with just an outline. You've got a lot of fill. And when you're working with something like a gradient, you've got a lot of different levels of fill. So if you have quick things that you can do to speed that up, freeze your ground covers, select new symbols that aren't gradients, that'll help. And you can always try a third-party plotter. We don't really recommend the DWG to PDF plotter that comes with CAD, just because the performance is kind of all over the place. Some files it works great, some files it's super slow. It was really fast in 2015. In 2021, it takes me 10 minutes to plot a file. So the third-party PDF plotters, that's what they do. Like, that program is there specifically for plotting to PDF. So the development time that goes into that is immense. Whereas the DWG to PDF plotter that comes bundled in CAD is a small portion of the application. So while it may work, there might be better options out there, more efficient options. Jeffrey actually had a good question on diminishing returns on added RAM.
Darn it, I just typed a reply to him. Now you're gonna probably say something way smarter than what I just said.
I caught it just before it disappeared. No, I was just gonna say there is absolutely, I mean, it depends on whether or not you want to spend the money. You're not gonna hurt anything by giving your computer more RAM, but you might also not gain anything. 16 gigabytes is more than enough for 90% of people out there, because Windows needs 4 to 5 at most. I mean, it'll eat more. I've seen that. I have a rendering system I built with 64 gigs, and Windows gets up to like 12 to 14 just because it's like, oh yeah, I'll have some of this. No. But for the most case, 16 gigs is more than sufficient. 36. I mean, if you want to go crazy with it, 32 gigs would be you'd never hit that. I mean, you could have a dozen CAD windows open and running and at least 5 Chrome tabs, and yeah, you'd be solid. No worries.
It could, but I mean, I've seen it. I think Photoshop is a classic memory hog, and it's very
Photoshop is
easy.
pretty heavy, yeah.
You could open a, say a 30 meg PNG file, and that will balloon to, I've seen it balloon to like a terabyte of virtual memory. It's amazing what can happen when you, especially if you're editing a video file. So, but if you're only gonna do that very rarely, who knows? But to me, it's just the classic thing. Obviously, you want the best monitor you can get, you want the best video card you can get, you want the most RAM you can get, you want the best processor, all of these things. And so, do you get a $10,000 machine? No. So obviously you weigh them all together, and you make some trade-offs.
Fortunately, most machines these days are upgradable, outside of laptops. If you're looking at laptops, definitely check with the manufacturer to see if they're upgradable. I know for a fact that no MacBook since like 2013 had anything upgradable except for the solid state drive. And even then, that's a proprietary drive that Apple doesn't sell separately. So you're kind of screwed there either way. So if you're going with a desktop, start with something reasonable. If you find you need more, you can always add more later. A little bit more of a nuance if you're sticking with a laptop, though. Okay, so how do you tell if you're actually looking at a design issue versus a configuration issue? Order of elimination. Are you running into this problem in every file or just one particular set? If you have multiple people in the office working on these files, is everyone having the same problem? That's a very quick way to isolate whether it's a issue on your workstation only, or possibly a problem with the file set. If you're looking at a delay in a particular function, time it. Some functions, like we were talking about, will take some time, so that's expected. But the plant symbol dialog loading shouldn't take 25 seconds. So time it, write that down, and that can help us, figure out what's going on. If you're accessing remote or networked files, like on an office server, like most offices do, copy those files to your local drive, throw them on your desktop, then open them and see if the same behavior is there. If it is, then you're looking at it, or likely looking at a design issue. If it's not there, you're very likely looking at a connection issue or latency problem to your files on the server. Okay, so as a quick example, just running a schedule takes a long time. Create a new drawing, add one tree. Is it still super slow? If it's not super slow, you're probably looking at a problem with that particular file. In the file that's exhibiting your issue, detach your extras, rip those guys out. Does it still perform poorly? That helps you eliminate either the base file as the cause of the issue or one of your extras. Anything you can do to reduce the number of variables. When you're trying to diagnose an issue, having 20 possible causes is a lot more frustrating to track down than having 3. Turn proxy graphics off. Proxy graphics are objects that your CAD doesn't have the object enabler for to display properly. So turn them off, get them out of memory, and see if you still have the performance issues. And lastly, if you're going through this and you have been trying to isolate it down, see if it's a design or a configuration issue, and you can't tell, send us a ticket. You can go to the FX admin ribbon in CAD. There's an arrow under the help button, and it's labeled support. You click that, and it creates a zip file on your desktop with the drawing set that you're working with and the LandFX project files and preference set that we need in order to help diagnose some of these issues. And make sure to include all of the testing notes from before. I mean, everyone's on a deadline, and I know whenever something like this goes wrong, it's like, oh my God, I need this fixed now. So obviously getting us the most information possible helps us get you the best solution in a timely manner. Because time is everything these days. So be as specific as possible in your description. It helps us get you to the proper solution as fast as possible. Uh-oh. All right, that about wraps me up, Jer. Did any other questions come up while we were going through that?
You might let's give everyone a chance to definitely chime in with any last question that made you think of. But definitely, I think the thing I would definitely emphasize, like Bennett just said, I think the main thing is considering what we have to do. When you come to us and you say, hey, it's slow when I do whatever it is you're trying to do, you say it's slow. Well, your definition of slow might differ from ours. And so, it's one of those things where, like, when someone says, when you're going to be here, I'll be there soon. That's not quantifiable. Let's pick some, it takes 35 seconds to open the plant manager. Oh, boom. Hello. Thank you. That was quantifiable. You actually spent a teeny bit of effort timing it. We now can immediately jump to some troubleshooting steps. So absolutely time things. And like you said, try different things. Definitely take the big monster DWG with all the XREFs that you're working on out of the loop. And let's see, is that just the case? And so obviously those can be, but like I said, we can still do things with that. You can still send in that monster DWG and say, wow, running a mainline sizing took 30 minutes. Well, hey, we'll take a look at that, and we might be able to update the mainline sizing function. Or it could be as simple as, yeah, you have a bunch of proxy objects. If you nuke the file, it sizes in 5 minutes. We've seen that as well. So hopefully this webinar armed you with a few things, I'm hoping, and definitely stay tuned for the hardware recommendations, because a lot of these might have clued you in that it's time to just simply buy a new computer. But anyway, all that being said, hey, guess what? Time to turn into a pumpkin. Let's go get some lunch. Have a great and safe weekend, everybody.
All right. Thanks, everyone.